So 12.6 is going to be mostly just calculator work, verifying that you can get the answers before we get to the equations, but we're also going to make sense out of what we're doing. So we're going to be dealing with two logs, primarily common logs and natural logs. So if I had log of 100, we should know that that is 2. Why do we know? Well, if there's no base, we know that's base 10. So 10 to what power makes 100? We could always check this. We could say the base to the exponent equals 100, right? So what if I said, what is log of 327? I don't know. But I know that it's between 2 and 3. And how do I know that? Well, 10 squared is 100, and 10 to the third is 1,000. So somewhere in there is an answer that's going to give me 327 between 2 and 3. Good news is your calculator is going to have a log button, log of 327. So that's going to be log, don't need to put a base, we're doing the common base, 327. And I said it's between 2 and 3. My calculator agrees, 2.51455. They'll probably have you do 3 decimal places, so like 515. Okay. Could I check this answer? Yeah, just like we did here, 10 squared was 100. I should be able to say 10 raised to the 2.51455 should approximately be 327. And I can do that. I'm actually going to leave as much of it in the calculator as I can, but I encourage you to check it. What's kind of funny here, remember how I said that logs are inverses of exponents, right? Do you see the log button right there? Look what it's matched with, 10 to the. Literally, they are inverses of each other. The log and the 10 to the are inverses of each other. So 10 to the answer to the previous answer should be 327. So I would encourage you not just to type this in and hit enter, but to actually check your answers. Okay? So what is log of 41,600? That's a little bigger than the last one, right? Well, we just said 10 to the third is 1,000, 10 to the fourth is 10,000, 10 to the fifth is 100,000. So it should be between 4 and 5. Once again, just logically, some people will mistype something and get like a weird answer. I'm logically going, I know my answer is between 4 and 5, between 10,000 and 100,000. So let's see. Log of 41,600. You got a calculator? Log of, oops, I keep doing that. I don't need it. Yeah, I actually had that right. What was it? 41,600. 4.61909. Is it right? Could you check it? What's the base? 10 to the 1,600. I'm going to just double check that. Okay, good. I did that right. 10 to the 4.61909 should approximately be, let's see, 10 to the answer should be, and some of you, your calculator's not going to keep the answer, so you're going to do 10, to the, and just put in how far we have, 4.61909, 4.61, geez, 1909. So put in as many decimals as you have, and it should be pretty close to 41,600. We just had some round off error, but don't freak out about that, right? What about log of 0.442? Well, I know that's going to be between 0 and -1. How do I know that? Well, yeah, because 10 to the 0 is 1, and 10 to the -1 is 0.1. So I'm somewhere between 0.1 and 1, so I know the answer should be between 0 and -1. Kind of weirder on that one, but just I'm saying logically you can kind of think about these. Log of 0.442, hopefully you got a calculator. Log of 0.442. Is that between 0 and -1? -354578. -354578. Could I check that? The 10 raised to that really flipping decimal, should approximately be 0.442. 10 raised to the answer should be 0.442. So that's kind of half of your homework, and I hope those are, like I said, the homework should be really easy. I would just encourage you to be able to check those answers, kind of make logical what you're doing and not just getting answers. But now we're going to be dealing with natural logarithms. See, natural logarithms are have to do with a number that shows up in nature. It has to do with when we have growth and decay of bacteria. I've even had, they said, I think like the way that on a pine cone, the ratio at which the spirals, how they come out and kind of, it goes in a rate of E. The point is, E is a number, approximately 2.71 mess, okay? And it shows up in nature. They actually discovered it by using logarithms on numerical sets that they saw in nature. This number kept popping up. And so they called it the natural number. So why do they have an E if it's called a natural number? Well, the mathematician that discovered it, his name is Euler. It looks like Euler, but it's Euler. And so he named it after himself. If you discover something, you name it after yourself. So it's called the natural number or Euler's number. So log base E, we just write as ln. You have an ln button, so you already have a natural log function in your calculator. If you're like, why, if it's natural log, didn't they put an L? Well, because it came from Latin, and so natural log in Latin would be, what, logissimus naturalis, or I know I sound like an idiot, but the idea is that we would flip that. That's the way those Latin kind of phrases work. So what is the natural log of E? That's basically like saying, what's log base E of E? Should be 1. Let's look at the calculator. Okay, let's start with what E is. We already said E was approximately 2.71 mess. Okay, but right above that E is this little ln. So what is ln of E to the first power? Should be 1. What is the natural log of E squared? Well, we know the 2 can come to the front, and so you end up with 2 times the natural log of E. That becomes a 1, so we're left with just 2. What's the natural log of 0.01? Well, that's going to be negative. Same idea with the tens. 2.71 to what power makes a decimal a negative exponent? So don't freak out about this. You got a calculator. What's the natural log of 0.01? Natural log of 0.01. Negative 4.60517. Negative 4.60517. Is it right? Check it. Does E to the negative 4.60517 equal approximately 0.01? Let's check it. E to the, I don't know why. All right. E to the answer should be 0.01. That crazy number raised to that other crazy number gives us 0.01. Natural log of 27. I'm going to guess that is about 3 point something, between 3 and 4. 2.71 is about 3. 3 to the third is 27. So I'm guessing it's probably, well, I know it's at least bigger than 3, but I'm not sure exactly. Well, let's check. Natural log of 27. I got a button for that. 3.29584. Is it right? We could check it. E to the that answer should be 27. And we're almost done. Natural log of 10.84. Something weird just happened. Let me fix that. 10.84. 2.38, 324. 2.38, 324, 324, and start throwing decimals in there. And e to the what the heck? Alright, I just lost it, so that'll be interesting. E to the, gosh dang it, where do I keep doing that? Okay, e to the, I'm going to have to do my decimals here, 2.38324, 2.38324, and I know there's going to be some round off error here. Should be about, I got 10.84, about 10.84. So hey, that's enough to even round it off. Sweet. All right, and then the last thing you're going to have is you're going to have word questions. Don't freak out about this. Look, basically they're going to give you this whole lengthy word question where there's logarithms that occur in nature, and they're going to want you to solve. And so this question had to do with x being millibars, and you have a function that shows up in nature where f of x was 51,600 minus 7,457 times the natural log of x. What if x were 400? Well, then we would just do f of 400, which means what? We go to the equation, and where there's an x, we would replace it with a 400. Can you do this in your calculator? I hope so. 51,600 minus 7457 times the natural log of 400. What did I do there? Dang it. Buttons, buttons. Who's got the button? All right. How about instead of 0, we do 400. Try that again. How about 6,921.65? 6,921.65. And that would be it. So don't make a big deal out of it. They're going to give you some functions, but they'll give you the equation. Plug in the value, get an answer. Just showing you how logarithms apply to real-life situations. Should be a pretty easy section. You are almost done with Chapter 12. Keep up the work.